Hello, guys. Good evening, everyone.
Good evening, ma'am.
Good evening, all.
Good evening, ma'am.
Good evening, ma'am.
Good
Good
evening, ma'am.
evening.
Evening all.
So last session we have discussed introduction to the UVM, right? What are the different features and what is meant by UVM and its evolution. So do you have any doubts in that? Today I will share you the material, everyone. Okay, the open source material and the PPT. So, and I will provide the assignments, regular assignments from today. So yesterday I have given some assignment, right, on system verilog to design a verilog program. What is that project? Calculator. I have provided the verilog design for the calculator. I told you to write the TB for the in the system verilog. Have you tried anyone? Have you tried that anyone? Lakshmi? Okay,
Yeah,
you
actually, I
told
am trying. Yeah,
okay.
I am designing this today.
What about others? So I already told you who are doing the assignments on time, who are going to submit the assignments on time. From this UVM batch, UVM workshop batch, we are going to select two people for further projects, okay, for free of cost on developing the RISC-V project or DMA controller projects and AXI VIPs. So we are going to take any two people. So if you it shows your interest, right? Through the assignments, how much you're working with the assignment and how much knowledge you have towards system verilog and the UVM, so that we can select according to that. That's why I'm providing some of the assignments for you. Okay, so today we'll start the session. Okay, yesterday actually we didn't took the session, right? So whatever we are going to discuss in the day 2, okay, how the UVM will work with the SOC level and the IP level, okay, and what is the UVM architecture and what are the class hierarchy, what are the different class libraries are there, the class hierarchy we are going to discuss today, okay? So whatever the doubts you have, please let me know so that we can discuss your doubts. Okay. This batch is good, I think. So you are interacting. Only 2 or 3 people are interacting, but not all. That's good. Okay. So coming to the system verilog TB, we already know the system verilog TB, right? So can you explain anyone what are these components and how these components will work? What is the intention of the generator, driver, scoreboard, monitor? Yes, yes, answer.
Hello, ma'am.
Go on. Yeah, hi.
So to verify our duty using the system Verilog TV, first we have to generate the stimulus that generator works, like generator do, and the generating the stimulus. Then,
Okay,
then to drive that stimulus to the duty, we need a driver, and we also have to monitor capture the output, what the duty is giving after applying the stimulus. Then we need the monitor. Then also we need a scoreboard to check whether the output which are generating from the DUT is correct or not based on our specification. Then all this is encapsulated within an environment. There is another hierarchy like levels of the TV, and that in that environment we connect the generator to driver and uh, the generator to driver and the monitor to scoreboard and the driver to duty and monitor to duty using the interface. and
Okay.
and generator
Okay.
to driver
Wait, wait, wait.
underscore to using the mailbox.
Okay. Okay. So, whatever the system Verilog architecture is there, so what are the updates we have taken to the UVM?
First, we added one more level, like
Any other
we
answers from?
hello.
Hello.
Yeah, yeah, yeah.
Noise, some disturbance noise is coming.
Yes.
Uh, so we have added one more levels like agent from the environment. Like we have
Config
added one more.
con
Hello.
Okay.
Hello.
Yes, Lakshmi.
Configurations
Yes.
we added to UVM
Okay. Okay.
and
What about
With
Amrita? Can you tell?
UVM,
Hmm.
UVM can like we can
Hello.
have multiple
Yes.
agents when compared to SV architecture.
Actually.
Okay.
Hello.
Okay. You just wait, Nagraj. Okay. So, compared to the system Verilog, some few updates got to the UVM, right? Like in place of generator, we have the sequencer and sequence and different and number of sequence items, right? So sequence is nothing but it have the sequence of transactions, whereas a sequencer will generate the number of sequences. That is one of next thing is there is another abstraction layer that is called agent, right? Another thing, in place of mailbox in the UVM, there will be TLM port, that is the standard protocol for data transmission. So this is the UVM architecture, right? So in place of generator, where in system Verilog the generator is used to generate the n number of stimulus, whereas in UVM, in place of generator, we are taking the sequence. Okay, so what is this sequence? Sequence is in the test level. Okay, within the environment, there will be the agents. Within the agents, there is a sequencer. Everyone, there are beginners also, right? So everyone see here, agent. This is agent 1 and agent 2. Why we have two agents here? Suppose this agent is related to IP1, okay, and this agent is related to IP2, okay. So in a DUT, this is our DUT. In this DUT, there are n number of IP. You know what is meant by IP, right? So what are the different types of IPs? Basically, just we may have some graphic processor, GPIO, or some core related processor, or some memory controller, or DMA controller, or DRAM, or AXI, okay, or AHB, or USB, or UART. There are different type of IPs will be there. So suppose this is one IP called memory controller IP. Okay. So this is one memory controller IP. Another IP may be GPIO or some AHB or AXI VIPs. Okay. So this memory controller IP, so DUT, consider here, this is the DUT. So this is one memory controller IP and here one GPIO. Okay, so for this memory controller, there will be one interface, that is a IP1, agent 1. This is agent 2 for another IP called GPIO IP. Okay, otherwise, in place of memory controller or GPIO, you are doing the transactions between AHB. Suppose this agent is related to AHB master, AHB master, and this agent is related to AHB slave. So one agent is the master, another agent is the slave. So in that case, we can call it as a write sequences, write sequencer, write driver, write monitor in terms of master. And here read sequence, read sequencer, read agent, read monitor, read driver. So these are the virtual interfaces we are interfacing with the DUT. Okay, so like this, every IP have number of agents. Okay, agents can have any multiple number of agents can be there for a DUT. Okay, according to our number of IPs or number of blocks. This is the UVM architecture, basic UVM architecture. Okay, so what is meant by sequence here? Sequence is nothing but it have the sequence of transactions. Sequence items will be there in the sequence. Okay, so what is mean by sequence items? Sequence items is nothing but, okay, in system Verilog, we will have the number of transactions, right? Or number of packets will be there. So same, that number of transactions are nothing but number of sequence items in the UVM. Okay, and sequence is going to generate the transactions. That means sequence is going to generate the sequence items. Okay, so that we are calling the sequence items here. Did you understood, everyone? Like that sequencer. Here there is a sequencer, right? What is the sequencer? Sequencer is nothing but a whatever it generating the number of sequences, it transferred that number of sequences to the driver, nothing but mediator between the sequence and the driver. Okay, just it work like a routing device. Whatever the transactions generated from the sequence, the sequencer will send to the driver. So the driver will have the information, like whatever the stimulus is there, that stimulus will be transferred to the interface via DUT, via interface. Okay, so the driver will convert the sequence item into the pin level for DUT. And coming to the monitor, monitor will convert again the pin level data, which is coming from the DUT, and it will send to the scoreboard and functional coverage. Okay, so scoreboard and functional coverage. If you see here, only one scoreboard, one functional coverage for 2 IPs. Okay, even if you have 3 number of IPs, 4 number of IPs, there will be one scoreboard, one functional coverage only. Common scoreboard, common functional coverage. Okay, suppose here there is a DUT. For DUT, we have IP1. Just a second. Whenever I'm drawing, you can also draw so that you will get the clarity afterwards. So suppose this is the DUT. In the DUT, you know what is meant by SOC. In SOC, what are the different IPs will be there? So suppose we have AXI IP here and AHB IP here, VIP we can call otherwise. And there is a memory controller, DRAM or GPIO or NBIO or SBIO, whatever, data fabric or control fabric, those are buses, right? So for all these, there will be a common scoreboard and common functional coverage. Here there is a common scoreboard and common functional coverage. For system Verilog also it is same. For all IPs will be connected to the common scoreboard and common functional coverage or reference model we can call. Okay, but how we are connecting in the system Verilog and how the connections are happening in the UVM. Okay, but so in system Verilog, we are using the mailbox, right? For communication between generator to the driver and monitor to the scoreboard, we have used the mailbox. By using the put and get methods, we created one mailbox and we just used the interface between the generator and the driver. But here we are using the TLM ports. Okay, so what is meant by TLM?
Transaction level volume.
So TLM is nothing but transaction level modeling. Okay, so here if you see from the sequencer to the driver, we are using one TLM port, okay, and monitor to scoreboard. We are not sending only monitor to the scoreboard. We are sending two different blocks: monitor to scoreboard, monitor to functional coverage. Okay, that means 1 to 2 different blocks. Okay, so if you want to use 1 to 2 different blocks, then if you see in the system Verilog, how we can communicate, we need to create two mailboxes in one class. Okay, mailbox is from monitor to coverage report, and mailbox is from monitor to scoreboard. Two mailboxes you need to create, and you need to do the transmission. But in UVM, we no need to create any mailboxes here. We have the TLM ports, analysis ports. Okay, so by using the TLM port and the analysis port, we are going to do the communication very easily. Here we no need to create the two types of ports. One port is enough, that is analysis port. In detail, we can discuss when we go into the topic. Okay, so I'm just telling the difference here. So here in TLM port, we have the export, we have the imports. By using the export and import, we can select what is the transmitter and what is the receiver. Sometimes you can make a sequencer as a transmitter and driver as a receiver, or a sequencer as a receiver, driver as a transmitter, like various from different agents and from different blocks. We can make use like that. Okay, so that's why it have the standard protocol rules. We are following some rules in the TLM communication. That's why it is very good for the communicating between various various agents, okay, in the complex level architectures. Okay, did you understood everyone? Did you got the clarity what is meant by UVM architecture?
Yes, madam.
Ma'am, I
Yeah,
have a
here
doubt,
I'm
ma'am.
having a question.
Yes, tell.
Ma'am, my question is that you told that functional coverage, we have a multiple IP for which we get the functional coverage. But my question is, if one of the IP is not working, or we are getting the results which are not expected, then how can we say that for all the IPs it is unfunctional? So shouldn't it be like for particular IP there should be different functional coverage?
See, whatever, suppose this is related to one IP and this is related to another IP. Both IPs doesn't have same test cases, right? Based on the test cases, we will write the coverage bins. Whatever the coverage bins are hitted, those whatever the test cases are passed, those coverage bins will be hit. Okay. So if test cases are not passing, the coverage bins will not hit. So whatever the test cases are not passing, you will work on those only. You will debug the error test cases only, right?
Okay.
Yeah.
Yeah,
Any
I'm
other
having question
questions?
here.
Yes.
Will there be any communication between agent 1 and agent 2?
Agent 1 and agent 2 will be not there. That
Okay.
see, communication between agent 1, this is agent 1 on agent 2 only, right?
Yes.
Here DUT, in the sense we are verifying the particular IP. Maybe here agent 1 is another IP, agent 2 is another IP. So IP to IP. If you take one agent is a master and another agent is a slave, then there will be the communication between agent 1 and agent 2.
Okay, what is that communication we called as? Means
Any
just like
register read,
monitor and
any
score.
register read,
Yeah,
that is
because here
one.
the communication between monitor and scoreboard or sequencer and driver will be like TLM here, right?
Yes.
In the same way, will there be any particular terminology
You're telling
mentioned
like
between agent
this
1 and 2?
agent to agent like
Ha.
this? No,
Yes.
that is not possible. Through
Why
the
I got this
virtual
doubt
interface,
because
you are communicating with the DUT, and this is from the DUT only. The data will be sent to the another agent.
But you mean to say this scoreboard is scoreboard and functional coverage blocks both are common to this agent one and agent two, means the environment whatever we are developing a code for scoreboard and functional coverage will be same, right?
Yes.
Okay.
Because
Fine. Got it.
see here, suppose this is one IP is related to the AXI, suppose if you think, and this IP is related to AHB. For AXI, there will be different number of transactions, different number of features you may need to verify. For AHB, you may need to verify different number of transactions, different number sequences, or different functionality. Okay, that's why there will be different agent for one agent for AXI and one agent for AHB to generate different test cases for both. And commonly in the scoreboard, we are writing common program for the just reference model. Reference model can be common. And also functional coverage, why we are taking common? Because for every test case, we'll write the common coverage report, right? So that's why these both are common. Whereas the sequences are generating the stimulus. Stimulus means it will generate according to our IP. That's why those are different.
Okay, got it.
Okay. Any other questions?
Yeah, like you have mentioned like AHB master and AHB slave, right? Like this two agent. May I know the functionality of this agent too? Then, if it is an AHB slave.
Okay, so if suppose if the what is the functionality of AHB and AXI first of all?
No, I'm not asking about AXI and AHB. I'm telling like
Okay.
you take it like AHB
One
master
is a
and
master
AHB
and
slave.
one is a AHB slave. Okay.
Yeah. So,
So
AHB slave should provide something to a DUT, right?
yes, yes. So
What will be
here,
that?
suppose mainly AHB, AHB and APB mainly we use for register configuration, right? Register configuration. So if it is working like a master, okay, and this is a slave, AHB slave. There will be a DUT for AHB master DUT and AHB slave DUT. So for both VIP, we are generating the test sequences. Okay, here AHB master agent means master is a design and also slave is also a design. Actually, normal, if in student level, what we do means if master is a design, we will write the slave as a test bench. If slave is a design, we'll write master as a TB. But here master and slave both are DUTs. For that, we are using one agent is for AHB master and another is for AHB slave.
Okay. And one more doubt is like, can we have multiple scoreboard in a like in a test bench environment?
Yeah, we can use a multiple scoreboards, no problem. For separate agent, if you want to generate every agent, you can generate. But commonly, if there are multiple number of scoreboard, multiple number of agents, because if there are
No,
10
I
number
need
of
a like
IPs,
when situation like when we can have multiple scoreboard like
yeah,
that.
you can develop. If there are 10
Yeah,
number of
we can.
IPs, tell.
Like how we have to take a situation like yeah we need a multiple scoreboard like that we have to decide, right?
Yes.
Can you provide an example for when we have to use multiple scoreboard?
See, that's what I'm telling. If there are 10 number of IPs, there will be 10 number of agent. Okay, every IP we are going to do the verification, right? So there will be 10 number of agents. If you want to write a scoreboard separately, how you have written in the system verilog, okay, when you are doing a project for the system verilog, the scoreboard is separate for that design only. So like that, you can write the scoreboard separately for every design. Suppose here there is a APB and there is a I2C. Before you have worked on APB or I2C, right? There, how you have generated the scoreboard separately for the APB in design itself, that means in TB itself, and I2C you have developed TB itself. So separately you can develop like that. Otherwise, you can create overall one scoreboard and you can write different scenarios for each IP.
Okay, can we have scoreboard inside agent?
No, agent means only 3 components it have: the sequencer, driver, and monitor.
No, I have seen using subscriber or scoreboard inside agent.
Maybe in system verilog you have seen, and some of the cases, but here we are taking commonly, right? That's why it is in outside the agent. If you are taking combinedly, you can put in the agent only.
No, like
Okay, I got your point. What I'm telling means here for two VIPs, I'm taking 2 separate agents. That's why commonly for 2 VIPs, commonly I'm taking one scoreboard outside. If you don't want to take commonly, you can write it in the agent only for this one scoreboard and for this one scoreboard.
Okay, and that driver to like we have a communication between driver to DUT, right? Similarly, you have another arrow from DUT to driver. Can you explain that communication?
See, here nothing but whenever the sequencer is generating the value, we are sending to the DUT, and in some cases it may require from DUT to the driver also in some scenarios.
Can you give me some example like that? Just
some example, yeah, we will discuss in coming sessions. When we discuss individually, we are going to discuss the sequencer, how to write the sequencer, how to write the driver, how to write the monitor. Everything we are going to discuss deeply, right? In the coming sessions, we can discuss. This is just for introduction.
Okay.
Yeah. Any other doubts? Others?
Hello, ma'am.
Yes.
Ma'am, you're telling that you can. There are 2 agents, no? So you're telling that there can be 2 IPs. Each one, agent 1 is 1 IP, agent 2 is other IP. So in that case, DT should consist of 2 IP designs, right? Is that possible? I don't think so. Is that possible? DT should at the time having 2 IP designs.
Why can't we take 2 IP designs? We can take 10 IP designs also in an SOC. In an SOC, there will be n number of IPs.
Yes. In SOC, as when we are going to compare, when we going to verify in a DUT, is there can we take 2 design IPs in DUT?
See, that's what I'm telling. This DUT is nothing but SOC. This DUT is nothing but a SOC. In SOC, if there are n number of blocks or n number of IPs, there will be n number of VIPs.
No. Okay. I'm not aware of this SOC verification. No, we have done IP level verification. That's what I'm asking.
Okay, IP level means only for the typing we do the verification. Internal blocks also we can do. For internal blocks also. SOC means for each IP there.
Till now we have done individual process like a PCI. For each IP we have verified. At the one time SOC level I did not verify. That's what I got it out.
Okay. Suppose if you are verifying only for PCI means suppose this is only the PCI will generate only for this block. One agent will be there.
I got it. Thank you.
Okay.
Yeah, here one question.
Okay.
Yeah, means every time whenever we are mentioning like agent 1 is 1 IP, agent 2 is 1 IP. Instead of mentioning that, I can say like one DUT here. DUT I can say is 1 IP, and agent 1 is a master, agent 2 is a slave. Like that, I can decide, right, in the IP level.
Yes.
When SOC level comes, obviously it is 1 IP. Agent 1 will be 1 IP. Agent 2 will be another IP.
Yes.
Okay.
Yeah. Okay. I think questions are over from your side? Okay, so this is what a simple SOC. So what is meant by SOC? Can anyone?
The complete system
System
on a
on
single
chip.
chip.
Okay,
System on chip. I mean, complete integration for different IPs is nothing but SOC.
okay. So what will be there in SOC?
In SOC, we will be having a lot of IPs like a PCI, PCS, and some other things, some other protocols related.
Okay.
There you have
Protocol
mentioned here no
transform.
DSP.
Okay. So SOC is nothing but a system on chip which have the multiple subsystems and multiple number of cluster of IPs. Cluster of IPs or nothing but subsystem. Number of subsystems integrated in a chip is nothing but SOC. Okay. So here, what are the different IPs are there? So this is a high bandwidth memory interface, and there is a processor, ARM processor, on-chip RAM, one digital signal processing, and MPEG, and one LCD controller, yacht, timer, keypad, PIO, peripheral IO, and some bridge. Nothing but for AHB to ASB. Okay, so already you got a clarity, I think, how we'll do the UVM verification here, right? So suppose this is one IP1, IP2, IP3, IP4, IP5 in SOC, here IP6, 7, IP8, IP9, IP10. Total 10 number of IPs are there. Okay, 10 IPs, 10 interfaces we can tell. So how many number of UVCs are required? What is meant by UVC? Universal Verification Component. Okay, so how many UVCs are required? So 8 number of UVCs are required. So all these UVCs will be developed from one company. Can we develop all the UVC from same company? Maybe you have some AXI in this only you have some AXI VIP and AHB VIP. Okay, so this is one another IP, 11th IP and the 12th IP. So is it can we generate all the things with the same company? Maybe some RAM, maybe we can buy some other IP vendor. We can buy the AXI from another IP vendor and AHP from some other IP vendor. So each IPs we can buy from different IP vendors. In the market, there are n number of companies where we can buy IPs. Okay, so if there are 12 number of IP, we can buy 12 number of UVCs from IPs from the vendors. Okay, so in that case, every UVC will come. Suppose here one UVC. What is mean by UVC? What will be there in the UVC? Verification component means nothing but it have the sequences of library. Okay, sequence library will be there along with with its own sequence. It will they will give along with the sequences. So here there will be memory UVC, and here there will be processor UVC, and there will be RAM UVC. Okay, like that every component will have the UVC. So in the UVC, what will be there? In the UVC, what will be there? Nothing but agents will be there. Okay, so in the agents, there will be the sequence, and there will be the driver, and there will be the monitor. Okay, sequence, driver, monitor, right? So that mean here we are not going to develop any VIPs here. We are going to buy. Can you please join for the next session quickly, everyone? So if you see here, I'm telling every component have its own UVC because we are not developing all the verification environment. We are buying the VIP, or if you see in IP level, we can IP different IPs from the IP vendor. or VIP from different VIP vendors, like that. Okay, so what when you buy any UVC from any IP vendor, what actually they provide? If you buy any component, you are buying a RAM, or you are buying a AHB, okay, and or there will be a IP vendors for AXI. So if you are buying a AXI, so what they will provide actually? So they will provide the stimulus, okay. So the IP vendor will provide the stimulus whenever we are buying the component, okay. So in that case, is it necessary to develop all the things from our side at the system level? No need, right? Mainly, we need to develop the sequences. Okay, see here, suppose we are buying all these UVCs. Okay, so what happens here? There will be different number of n number of sequences here, n number of sequences here, also n number of sequences, and from this we can generate n number of sequences. Already these stimuluses are providing by the IP vendor. Okay, so at the system level, as we are the verification engineer, we are going to write only the top level virtual sequences. Okay, so what is the virtual sequence here? Virtual sequence is nothing but the sequence of sequences. So here, whatever the sequence here, from the sequences here, and from here, the sequences, and here, all these sequences are connecting to the block that is called as virtual sequences. Okay, so we are going to define how to drive all the sequences at the system level. Okay, so first we need to suppose here there is a IP called yacht, or there is a one PIO, peripheral IO, or there is one GPIO. Okay, so how we can drive the sequences here? First, we need to reset overall SOC, and we need to drive some sequences from the yacht, or if you take the AHB, mainly we can drive the register sequences, and finally we can drive those stimulus to the yacht, because the bus is like this, right? So we can drive the stimulus to the yacht. Like that, if you want to drive two sequences at a time, suppose if you want to do the functionality parallelly two interfaces uh, for this LCD and the yacht. So what we will do? First, we will reset the device. Then we need to do the register configuration. Register configuration means everything, the data will be stored in the memory only. The read and write data, everything will be stored in the memory. So register configuration is important. Okay. So after that, we need to check the status of the register, and we can drive the stimulus of LCD and the yacht parallelly. Okay, so that what we need to do, we are connecting to the virtual sequences. Okay, whatever we are writing n number of sequences in the virtual sequence, through that we can drive all the VIPs, all the blocks. Okay, so this is what actually happened at the SOC level. We can discuss very detail about the virtual sequence and what is meant by virtual sequence, how we can drive the stimulus, everything in the coming sessions. Okay, did you got the point, everyone?
Ma'am, we have doubt. I have doubt, ma'am, actually.
Yes, tell.
Myself. Actually, we need to buy this UVCs, VIPs, right, ma'am? Every VIP we need to buy when we are going to verify in SOC. Suppose we have verified PCA, so we have to integrate in SOC level. For what we have to integrate PCA into SOC level. For that purpose, we need to buy all these things, ma'am, from vendors.
Yes.
It costs too much, no, ma'am.
It costs too much means we can reuse those anywhere. Suppose we are buying one AHB here. Okay, that one AHB we can reuse for entire SOC. There are many we can put this one AHB everywhere. Okay, for every IP interface there will be AHB, right? So you can put all those you can reuse all the AHBs everywhere. That's why it is highly configurable and reusable UVM. And most of the UVs, suppose if any VIP is there, maybe some some companies have their own VIP. Whatever the needed or there, they will buy from other vendors.
Okay, madam. I got.
Okay, cost in the sense they will manage.
Okay, madam. So okay, madam. And whatever the updated IP is there, no, we will verify and we will integrate in SOC by buying when UVs VIPs from other vendors. That is the thing, no, here.
Yes.
Okay, ma'am. Thank you.
Okay, same. If you see IP level, what will be there in the IP level? There will be one. Suppose we will consider one IP here. Suppose yacht to timer, okay, or some AHB to yacht. Suppose here there will be AHB or APB, yacht to AHB, or any PIO to AHB. So what will be the test bench hierarchy? I mean, what will be the top level? Can you tell me? Anyone? Suppose here there is a yacht and I'm in the IP, there is a GPIO. Okay. So how we will create the environment for these IPs?
We will have two agents for the UART and one for the GPIO.
Okay, here there will be one UVC, and here there will be another UVC. In the UVC is nothing but in that it will have agent, and here it will have the agent. Okay, in the agent, what will be there?
Driver monitor sequencer.
Driver monitor sequencer. So here there will be one sequencer, here there will be one sequencer. Okay, next.
Interfaces.
We can create one virtual interface, virtual sequencers for these two sequencers.
Virtual sequencer.
Virtual sequencer. And for these agents, we can create one scoreboard and one coverage model. This is what actual environment. Okay, did you understood everyone?
Yes, madam.
Okay, do you have any doubts?
Yes, ma'am. Like, ma'am, what is the main difference between the VIP and UVC?
VIP is nothing but verification. IP, UVC is nothing but component.
Means
Verification
what will
component.
means when we are saying VIP means they are providing complete verification things. Only we have to apply the like our stimulus.
Okay.
In the UVC, then what they will provide?
Okay, good question. Can you work on this? Why I need to tell all?
Okay, we'll try.
What is the difference between UVC and VIP? Get that answer by tomorrow, okay? Any other questions other than that? Any questions?
Yeah, how the SOC verification is different from IP verification?
Okay. SOC verification is nothing but it will have a number of IP, group of IPs. If you do the verification, that is SOC verification. For IP verification, we do the only block. I will share you one video. Okay, there I have discussed very clearly on the SOC verification and IP verification. You can go through that. Okay, for SOC verification, why we use the C language and C++, why we use IP verification only UVM and system verilog. So how we do the processor verification by using C++. So all these things you will get. Okay, you can check there.
Yes.
Okay. Yeah. Any other doubts here, everyone?
Okay, madam. Done.
Okay. Okay. Another thing, okay. Suppose here, if you are doing, okay, we already discussed. Next one, chip level UVC. Whatever we have discussed up to now. So how we will consider the UVC. Suppose here there are three inside the CPU. Inside the design, there is a CPU, memory subsystem, peripheral subsystem, and this is another peripheral subsystem, or you can consider as a IP. So for peripheral IP, we have considered one UVC and another interface, one UVC, and for this bus, another UVC. Okay, bus VC. So from all these UVCs, we have taken sequences to the virtual sequencer, and as a user, that means our work is mainly how we are creating our own scoreboard and how we are connecting the scoreboard to the monitor and how we are writing the virtual sequences. That is our main, as a SOC verification engineer, we need to do that thing. Okay. So whatever we are buying the UVCs from different possibilities, different company, there are different possibility. That means we can use and we can reuse the same IP at a system level or IP level. If there are if the company owners are not accepting for reusability, we can develop our own VIPs. Okay, that will be one case. Suppose suppose the industry have lot of developing verification UVCs like a PCIe or AXI or other standard interfaces out there, right? We can also talk to the VIP vendors apart from IP. So there are so many possibilities out there. So our main work is whatever we are buying, we can write the virtual sequences and we can create the scoreboard and the coverage analysis coverage report. Okay, this is what actually happen in the chip level or SOC level. Okay, clear everyone? Another thing, before one person asked, like here, what is mean by CFG? CFG is nothing but configuration. Okay, another advancement in the UVM is a configuration facility. By using the configuration facility, we can configure according to the user, according to the specification, not according to the user. According to the specification, according to the requirement, we can configure. That means if you want to use only the master and the slave agent, we can take how many masters and how many slaves. If you want 3 number of slaves and 4 number of masters, we can select that thing. Or if you want a agent, suppose here agent is there. In agent also we have different number of agents. Okay, like active agent, passive agent. Active agent means which can generate the sequences. Passive agent means it doesn't generate the sequences, just for monitoring the data. we discussed in the coming sessions. Like that, we can configure the data. We can configure the according to the requirement. That is the CFG block. Okay. So this is what chip level UVC. Everyone understood? We can UVC we can also call as functional model or a simulation environment, because it is mainly creating the simulation environment. Okay, even if we don't have the design. Okay, suppose here there is a memory and there are two other peripherals and there is a CPU. There is a design only for CPU. We don't know, there is no RTL design for memory or other two peripherals. So how can we do the verification in that case? So in that case, we are creating all UVCs here. Okay, for monitor, for bus, and for other peripheral, we are creating the functional model. Functional model is nothing but UVC. Okay, so by that, by using the UVC, I can easily create the simulation environment for the for that RTL. Okay, RTL in the sense, according to the RTL, already UVC will be developed, right? So by using that simulation environment, we can create the sequences, virtual sequences, so that we can verify overall SOC. Okay, if you want very clearly. Is there any doubts still?
Hi. This functional model and bus functional models are same, like you're talking about bus functional model while
Bus functional model is nothing but for verifying the bus like AHB or APB bridge or bus interfaces. Peripheral means a block component level.
okay. So we are mimicking the IP as a functional model.
Yes.
Okay.
Any other doubts?
Ma'am, driver and bus function model is same or differently?
Driver?
And bus function model?
Driver and bus functional model is same only. In UVM, we will call as a bus functional model. In system Verilog, we will call as a driver. That is just names difference.
Okay, ma'am.
Yeah. Okay. Is there any other doubts?
One doubt. Do we need a virtual sequence in this DB?
In this DB, yeah, virtual sequences are required. Virtual sequence means if there are multiple number of components, then only we can generate the virtual sequences for all. In place of generating sequences for each IP separately, we can create one virtual sequence. We will discuss exactly what is meant by virtual. That means how we can create the virtual sequence. Those things we can discuss briefly in the coming session. But virtual sequence means whatever the here it is showing, right? For this VIP, there is a one sequence, and here we need to generate n number of sequence. See, another thing. Suppose suppose there is a AHB. In this AHB, I want to create a n number of sequences, like a 4 number of sequences. So how can I create? There will be 4 agents. 1, 2, 3, 4. That means here there is one sequence, here there is a 2 sequence, here there is a 3 sequence. All these sequences I can take into one virtual sequence, and in the virtual sequence I can generate all the sequences for those without taking separately here sequence, here sequence. If you take separately, what happens? For this sequencer, we need to create one sequence outside the top module, and here there will be another sequence outside the environment, I mean in the test. Here there will be another sequence in the test. That will be complex, right? Without taking like that, we are taking one virtual sequence. Wait, I will show. See, if there are for AHB, I want to generate 4 number of sequences. That means 4 number of agent 1, agent 2, agent 3, agent 4. For 4, we should have outside like this sequence. 4 sequences will be there. In every sequence, I want to write the scenario. But in that case, in that place, if we take one virtual sequence for all these, it is simple. Is it clear?
Yeah, so in that means every time I need to use the virtual sequencer to drive all the agents.
Yes.
But if my test scenario requires only putting or driving only one agent, that has to be separate.
Then you can generate separate sequence.
Okay.
Yeah. Next one is UVM TB architecture. I think from before blocks, you already got the clarity. What is meant by configuration, what is meant by agent, coverage collector, sequencer, driver, every block, I think you got the clarity. So checker is nothing but like a assertions. Will do the checkers, right, for the DUT. So that is the assertion type in system verilog, and separate clock generator and configuration settings. Configuration settings means nothing but how many number of masters are required or slaves are required, or you can select whether it is an active agent or it is a passive agent. We have the configuration methods will be there. Okay, by using those methods, we can do the configure. We can view the details of configuration. So that is configuration settings. So sequence 1 and sequence 2 is from different agents. Okay, and next one. So here is another important test bench architecture at a IP level or any SOC level, mostly IP level. So can you observe one thing from this block? What is the different one? Whatever we discussed up to now, what is the difference you have seen, you have observed here in the
Register
DUT?
model some in the DUT.
Environment.
We have added the RAL model.
Okay. What is meant by RAL model?
To verify the DUT registers and memory.
Okay, so up to now we have seen different IPs like normally GPIO or some UART or I2C or AHB like that, but we didn't discuss how we will verify the registers in the DUT. Okay, so if you see, test cases are different from the registers, right? So up to now we have what we did. We generated the sequences for the particular DUT. Suppose if it is a yacht, okay, for yacht, what are the sequences we can generate? What is the address? What is the data? Like that, some of the sequences we have generated by using the virtual sequencer. Okay, but how can you generate the register data? So by using the normal virtual sequences, we cannot generate the register data because register sequence is different from bus sequence. Okay, bus sequence is in a binary format, whereas a register sequence is in an address register map format. Okay, so that's why register sequences are different and bus sequences are different. So if you see here, here register RTL block is there here, and there is another RTL block. So transmission between register to another user RTL block. Okay, so to verify these registers, these internal registers, okay, we need to create one RAL model. RAL is nothing but RAL. RAL is nothing but register abstraction layer. Okay, register abstraction layer. So how it is different from normal sequencer, normal virtual sequence? That's what we discuss here. Okay, see, suppose in the RAL model, so this is all RAL model only. Okay, if you observe how it is different from normal driver, monitor, sequencer, so see here. First, there will be register sequence library here. Register sequence library. From the register sequence library, we are sending to the sequencer, and here there is a agent, sequencer, driver, and the bus adapter. Okay, and here there is a register model, model updater, and the signal interface to the driver, and here VIP agents to the coverage collector, and here VIP sequence library and custom sequence. Okay, so if you see here adapter, actually it should be I think here the communication should be like this: register sequences to the register model, that means adapter. Okay, the communication should be like this. So here mainly the register sequence will drive the register stimulus. Okay, the register sequence library generate the register stimulus. Mainly it is used for the abstraction layer is used for modeling the memory mapped registers and the memories in the DUT. Okay, so for that we are it should have the register model, adapter layer, and the predictor. Here predictor is not mentioned. Predictor will be there when we discuss in depth of the concept. There I will tell you clearly. So a register sequence library is nothing but it drives the register stimulus, and the register sequence doesn't generate the binary, so that because it doesn't accept the binary, the driver doesn't accept the binary data directly. Right here, driver, it doesn't accept the binary data. For normal stimulus, the sequencer is generating the data and driver will accept the binary data. But whereas here register sequence means it generates the register data. So whereas the driver doesn't accept the data directly. Okay, so for that purpose, this register sequence need to convert into the bus sequence. Okay, these register sequences need to convert to the bus sequence. That bus sequence is converted by adapter layer, nothing but bus adapter. Okay, register sequence need to convert it by the adapter. Okay, so based on the register sequence, the register DB, here the register database, register model, register database is not given. Okay, there will be a register database that will be updated. Okay, so here okay, so that is how we are generating the data, and this bus adapter will convert the data into the binary format, so that from the bus adapter we will give to the driver. Okay, that is what actual the RAL model there. Okay, everyone understood here? Diagram is not properly mentioned. So actually we will do like that. In the RAL model, there are so much things we need to know, like what is the front door access, what is the back door access, what is mean by predictor. Okay, predictor is nothing but whatever the data we are taking into the register, the data will be updated in one database. That is nothing but predictor. By using the predictor, the data will be updated. Okay, did you got the clarity here? Is there any doubts? once we go to the in-depth of the concept, there we will understand what is meant by register map, how the sequences will be generated using the register map. Okay, what are the adapter methods? So here it is converting the data into sequence to register sequence to bus sequence to register sequence, right? So that it will have some methods. So what are the methods? We can discuss all those things. So types of predictors will be there, how the data will be predicted, like auto prediction or explicit prediction. So these all things we discuss once we enter into the concept. Next thing, have any doubts here, everyone?
Yeah, that signal interface driver is there, right?
Okay, where?
Yeah, near to this register
Signal
model.
interface driver.
Yeah. May I know what is that?
Signal interface driver means that is cutting from custom sequences. No idea. Signal interface driver means nothing but that it is driving the data from register sequences, because here the custom sequences are getting here, right? Here custom sequences is getting the data here, n number of sequences the driver is sending to the coverage collector. Maybe that data, actually the register RAL model is, we should have the register sequences. Here the sequences will be generated. Whatever the register sequences is there, the adapter will convert the register sequence into the bus sequence, and it is given to the driver. From the driver, it will send to the DUT. From the after sending to the DUT, again it will send to the driver, and then again the adapter will convert that bus to register sequence. That will be taken into the predictor. It will predictor will get the updates. Okay, and it is the front door access. If you go to back door access, we don't have the driver directly here. There will be another adapter in the predictor, so that it directly store the data. This is what actually register transfer. But here the signal interface is nothing but it is getting some custom sequences from VIP sequence library, because in UVM we have the sequence library, right? And also it is getting the data from the register sequence library, so that it is sending to the driver and going to the collector report, like coverage collector.
And one more doubt is like when actually this virtual sequence is required actually.
Virtual sequence.
Yeah. Yeah, here we have used sequence library in IP level, right? So similarly,
VIP sequence library. Okay, here register sequence library, because here we have an different library class libraries. So by using that we can configure accordingly. Virtual sequence is nothing but, before I told you, when there are n number of sequences, we will connect all the sequence to one block. There we generate the n number of scenarios. For all blocks, we'll generate the data from one block. That is nothing but virtual sequence. Once when we enter into the conceptual wise, there you will get the clarity. Just wait.
No, I just want to know like how the sequence library and the virtual sequence differs.
Sequence library means it have the n number of class definitions. Library is nothing but it have the class definitions or component definitions. See, everything we are UVM is nothing but we are creating from the library only, right? All are like if you take any generator or sequencer, it is derived from the parent. Wait, I will show you. For this, you will get the clarity. Okay, everyone clear up to here? UVM TB architecture, everyone clear? Okay. Is there any doubts? Clear, everyone?
Ma'am, you will show this TB environment in a manner of code after
Yes.
sections.
Yes.
Okay, because
We
seeing
are
like
going
this,
to discuss, yes. We are going to
by
discuss
seeing,
every topic clearly. See, I have mentioned, right? So what is the 15 days?
yes.
First, today is the overall SOC level and the IP level. And we also
Yes.
completed the architecture and hierarchy we are going to see now. And next session, how to write for sequencer, driver, monitor, and then for agent, scoreboard, environment, and then what is the factory registration, phases, like that, stimulus modeling, and what is meant by TLM ports, callbacks, RAL model. So everything we are going to discuss clearly.
No, actually, by seeing this image, I mean,
Okay.
pictorial view,
Just a
I
top
cannot
level
imagine.
explanation. Yeah.
Okay.
Okay.
I cannot imagine what is the process going in internal code. That's the reason, actually.
Yes.
Okay.
Okay. So any other doubts? Can you please join for next session? One more session. We'll just discuss this class hierarchy and we'll close the session. Please join again. Okay. So here you have asked what is meant by VIP sequence libraries, right? So here we are going to discuss UVM class hierarchy. So basically UVM means universal verification methodology, right? A methodology in the sense compared to the system verilog. In system verilog we have different topics on how to generate the stimulus or for randomization or for coverage analysis or for assertion, everything we have clearly. Okay, but why we move to the UVM? Because it is a methodology which have set of libraries. Okay, whatever the individual topics we are developing in the system verilog, everything from the scratch, we are not developing everything from the scratch in the UVM. By using the class based base libraries, there are lot of base libraries, right, which have the class definition inside the library. So by using those, we are able to develop any TB very easily, because already the main definition, main functionality will be inbuilt in the each component. By using that, we are recreating our own sequences. Okay, right. So what is meant by class hierarchy? What are the different libraries are there in the UVM? So that's what we are going to see here. So from past few years, if we see, there are a lot of libraries in the methodology. So currently we have nearly 250 to 270 class library definitions. Okay, so the library contains nearly 250 class definitions. Okay, so what are those? We'll see now. Okay, so if you see here, first one, UVM object. So what is mean by UVM object? So whatever you want to create any object, if you want to create the object, first we will derive that from UVM object only, right? So some packet is derived from UVM object, like that, whatever we have used in the system verilog. So this is the virtual UVM object is nothing but it's a virtual base class for all components and for the all transactions in the test bench. Okay, mainly the main role of that UVM object means it have the set of methods like print method, copy method, clone method, compare method. These type of methods will be there. Okay, so what by using those methods we can create any object. right? So that means it have the pre-built library. We can easily access those. Okay, the objects can easily access those methods. Okay, like that. Next, if you see, before the object, we have two parent classes. So first parent class is the void. Here there will be UVM void. From the UVM void, UVM root. UVM root is the child class for UVM void, and then UVM object. UVM object is the child class for the UVM root. Okay, so what is meant by UVM void? Like same like this UVM report is there, like right? Like that same there will be UVM void. So void in the sense it doesn't contain anything. It doesn't have anything. It just have the parent like a parent class. It is a parent class to all classes. It just act like a parent. Okay, it doesn't contain anything. Okay, did you understood? UVM void is nothing but it doesn't have anything. It doesn't have the data member. It doesn't have the functions. Okay, it just allow the objects to create, just like a void pointer in the C program. Void pointer means it doesn't have anything, right? So UVM void means nothing, just like a parent. And then UVM object, and then UVM root. UVM root means it is a top level component. Basically, whenever we define some test bench architecture, which is going to be instantiated in the test. Okay, top level is the test bench architecture, and next one is the test, right? So the test is going to be instantiated with a UVM TB top level, which is nothing but an instance of UVM root. For that we use the UVM root. Okay, and then UVM object class is derived from the root. Root is a parent class. UVM object is the child class, and UVM object is the parent class. For that UVM report is the child class. Okay, so what is the UVM report here? UVM report means, please note down the points. Okay, it contains the configuration data. It will generate the reports. Okay, and there is a UVM component. UVM component is the child class for UVM report. Okay, and report means it all have the messages like warning messages or error messages. And it have the report handler, and it have the configuration data. Okay, whatever whatever the configuration is handling, it is making the decisions, and it will print the data, right? So everything will be there in the report. From that there will be report mechanism. In the report mechanism, we'll have all just a second. Okay. Sorry. So here everything in the report means it will have the verbosity levels, UVM medium, UVM information, UVM warning, UVM error. Okay, UVM high, UVM mid, UVM low. All verbosity levels will be there in the report. Okay, and then UVM component. UVM component is nothing but whatever the components like agents or driver or scoreboard or monitor, everything these are under UVM components. Okay, so every child class can access the properties of the parent class. That means every component is a child of the report object and grandchild for the UVM object, right? Is that correct? So every child class can access the properties of the parent class. So it will extend the classes from the UVM classes because already the logic is predefined in the library. Okay, if you take the report mechanism, already the logic is predefined in their methods, in their verbosity level. Like if you take the objects, already the data, the functionality, the class definition is already there in the copy, clone, print method. Just we can use the methods. Okay, like that here if you take a sequencer or a driver, okay, so if we inherit the UVM sequencer, already it have the router logic in the UVM sequencer, no need to define it again. Okay, so that is what the class definitions already inbuilt in its own uh, in its names, nothing but library. Okay, so for every component, the UVM infrastructure has dedicated the available classes in the UVM libraries. Okay, so that is what. And next here, there is a TLM. TLM is nothing but the communication between the components, right? We are making TLM predefined interfaces are there. So TLM predefined interfaces we'll discuss in the coming sessions. What are the different interfaces? And if you see here, UVM sequence item and UVM transaction. UVM transaction is for objects, and UVM sequences are nothing but you have to define your own packets by extending the UVM sequence items, right? So for that, UVM sequence items are going to be generated in the sequencers. Okay, so this is what the class libraries where we are going to inherit all the components or objects or items, sequence items, everything. So clear, everyone? So for if you see here, if you want to use this copy, clone, print method directly, we can't use. We need to go for factory registration. Without doing the factory registration, we can't use these type of methods. So we are going to discuss all those things in the coming sessions. Everyone clear up to here?
Yes.
Ma'am, may I know why only UVM sequence item and UVM sequence are derived from UVM object?
Okay. So will do we write UVM sequence items from the component? Will they derive from the component? We will generate from objects only, right? Sequence items. Not for the components, right? What is the difference between object and the component? Okay,
Object
my
has
question.
only like, yes.
Tell them. Okay, so why TLM is connected to component? Why not to object? And why sequence items are connected to object? Why not to component? Very simple question.
Ma'am, so everything which are used to create the like to generate the stimulus that will be extended from the UVM object, and for the component that are the part of the hierarchy of the TV that we will extend from the UVM component.
Okay. Okay. Everyone got the answer? Any other
Yes,
doubts?
ma'am.
Okay.
Uh,
By using the TLM only, we are connecting all the components at top level. But from the objects only, we are creating the sequences. That's why. That's why UVM object is the parent for the UVM sequence. In case, see, UVM object is the you need to understand and the logic here. UVM object is the child class for UVM sequence means UVM component is also a parent only, right? Because UVM component is a child for UVM object. For these two, UVM object is the parent. That means it can access from component also, right? For both, it is a parent only. Okay, okay. Any other doubts?
Yeah, I'm not clear with the description you have provided for what is the difference between UVM component and object. Can you explain that once more?
See, what I'm telling means here, you told like why we are not connecting with the component, right? For UVM component and UVM sequence item, for both UVM object is the parent. Okay, component is also inheriting from the UVM object only. Like that sequence also inheriting from UVM object only. We are no need to mention UVM sequences with the component because component is different. Every sequence we need to generate from the object only, right? That's what I'm telling.
Okay, I understood that. I'm asking like what is the difference? Like what is the difference between object and component?
Just
See,
search,
the
just
UVM component is a static in nature, okay? UVM component is a static in nature. UVM object is a dynamic in nature. So the UVM object, it is means it is a dynamic in nature, means it will be limited time only. Okay, that's the one of the difference.
One adding point is that UVM developer, when they are creating this methodology, means the common part that we can write in the while creating the stimulus class, that will be added in the UVM object parent. So if we'll extend from the UVM object to create our stimulus class, then it will be very easy to create that. Both are the different UVM object and the UVM component. That will be only for the easiness of our like.
okay, that's good. Still, do you have any doubts? Okay, okay. We'll see tomorrow then. Tomorrow how to write the sequencer
I have
driver.
still doubt regarding this DLM port. You told like we couldn't connect DLM port to objects. May I know why?
Okay. Can you tell me what is the need of TLM?
DLM is for communication.
What communication? Where
It's like
we
between
need to
blocks,
communicate? Huh?
like between the components.
Between the components. Then where it should be there?
It should be connected to components.
Components. That's why.
Okay, and
We
I'm
cannot
not
connect to the objects, right? We are not
Hmm.
connecting object to object. We are not connecting the driver objects to the monitor objects. We are connecting driver to the monitor. We are not connecting object to the object. Right, that's why for TLM component is the parent, not object is the parent.
Okay.
Okay. Still, is there any doubts? Okay, then thank you all.
Yeah, thank you.
Thanks.
Thank you, ma'am. Bye.
Thank you.
Thank you.
Ma'am, you will share this recording, right?
Yeah, I will share.
Yeah. Yeah. Okay. Thank you.